Hello, everyone. Welcome to Race Math Plus. I know everyone had math methods are hardly preparing for the incoming final exam. So today I bring out my favorite topic about the math methods exam 2, the probability and the statistics. So this question is from the 2021, the Northern Hemisphere. The test normally runs in the middle of the year, so that's different with our Southern Hemisphere part exam. But our topic and the curriculum are exactly same, and they do a very, very good prediction about the final exams. So first thing first, let's go through the questions informations. A particular petrol station has 2 air pumps, A and B, to inflate tires. Each inflation of a tire is independent to any other inflation of tire. When a pump A is set to 320 kilopascal, the pressure that the tires will be inflated to follows a normal distribution with a mean 320 kilopascal and a standard deviation of 10 kilopascal. Find the probability that the tire will be inflated to a pressure greater than 330 kilopascal when inflated by pump A, correct to 4 decimal places. Exam 2, we would use the cast to help us. Now, this is a very typical introduction, like part A to initiate all the questions. From the given informations, we would know that the mu, which is the 320, and our theta is equal to the 10. And then we can use the function, the menu, all right? And then the probability distributions, and we're gonna do the normal CDF, all right? And after we do the normal distribution, we directly can read the answers from the calculators, and must be careful about the requirement from the questions. If the question mentioned 4 decimal places, then we keep 4 decimal places. But sometimes, occasionally, the question would ask like for significant figures. So please distinguish them. The first question, very easy, 0.1587, all right? And second one, the probability that the tire is inflated by pump A to a pressure greater than A is 0.9. Now we are looking for the A value. So we would know that with the given probability, we're looking for the bound, that we would use the inverse normal distribution. Please remember one thing, that in our calculator, we can only do the probability for the variable less than the value. But the question provides us greater than value probability is 0.9. Look, we're gonna apply the complement event. Greater than A is 0.9, then less than A gonna be 1 minus it, which is 0.1. So we will input the inverse norm, area is 0.1, the mu is 320, and the theta is 10. And then after we round to the nearest kilopascal, which means the nearest whole number, 307 kilopascal. All right, 307 kilopascal. And now B is set to 320 kilopascal. The pressure that the tire will be inflated to model by the following PDF. So by the given PDF, we will focus on the equation and also the domain. Okay, and when we determine the mean tire for the PDF, we will looking for the definite integral over the domain for the variable times its PDF and dx. Use your calculator, the menu, calculus, and the third one, the integral. Input the value and everything done. A trick, please define the bx first. So in the following question, you don't have to repeatedly type again and again and again. And the answer is 322. All right. And for D, A randomly selected tire is inflated by the pump B. Find the probability that this tire will be inflated to a pressure greater than the mean tire pressure of the tires inflated by pump B, correct to 4 decimal places. Now, we are looking for the probability. So we just doing the definite integral over the PDF. But what is the bound? Look, we are doing the question between, right? More than the mean, but less than what? Less than the upper bound, 330. So we need to use our mean just to find out. So that is the connection between each question. If you make a mistake on C, you can't make it D. All right, use your calculator. You can find out this value is actually a finite decimal. It is 0.5248. Now, everything easy. Turn to the next page. The probability that a tire is inflated by the pump B to a pressure less than K is 0.95, right? 0.95. Find the value of K correct to the nearest kilopascal. Now, we are doing what? Okay, we are now looking for a specific value in between the domain from 310 to 330. And between 310 to this amount, this value K, the probability is 0.95. So you have to solve it. Either way, you can work it out by hand or solve. And then looking for the 310 to the K, what is the definite integral over the PDF, right? Equal to 0.5. Please announce your argument again. In here, if the argument is not X, it is K what you're looking for, all right? And then you can round your K to the nearest whole Pascal. That is 328 kilopascal. For the extended response, if the question has unit, then you better put the unit next to it to clarify. All right? F part. A motorist is equally likely to use either pump A or pump B to inflate one of their tires. Find the probability that the motorist has used pump A, given that the tire is inflated to a pressure greater than 325 kilopascal. Give your correct answer 4 decimal places. Now, this is a what type questions? The conditional probability. Everything after the given is the condition, okay? So we are looking for the probability we select A, given that the pressure is greater than 325, which means you have to looking for the A intersect with the greater than 325, and then for the probability greater than 325. Now, for the probability we select A, that is a half, because it's equally likely to select either A or B. So half. And then we're going to multiply the A greater than 325, right? So you're going to do the normal CDF. And you can trace your answer at the beginning, all right? It is a normal distribution, mean 320, and the standard deviation 10. And you can find out what is the probability that the inflation greater than 325, okay? And then for the bottom, first thing first is the A multiplied with the normal CDF. And then you're gonna plus another one. What if you select the B? First thing first, select the B is a half, the probability. And then the second stage, you have to greater than 325, and you're gonna do the definite integral over the PDF from 325 to 330 bx dx. And this is how we find out the complete question answers. You can throw in the completed expression, press the enter in your cast, or you can work it out by part separately, this part and then next part, and make an extra working steps. But finally, you have to round your answer to 4 decimal places, and that is 0.5411. Next, the company that manufactures the pump tests all of its pumps and removes those that are defective. The probability that a randomly selected pump is defective from all of the pumps tested is 0.08. Look, typically the sample proportion questions, this 0.08, that is a little p or the population proportion, all right? Find the probability that 4 pumps are defective from a sample of 25 randomly selected pumps, correct to 4 decimal places. What type of the distribution for this one? We had discrete and finite numbers of the sample numbers, and each sample only has 2 outcomes. Either way, be the defective or not defective. It's binomial distribution. So it follows the n number of the trial, 25, and the defective probability, which is a success, 0.08 at here. And then we are looking for what? The binomial CDF or binomial PDF. Look, binomial PDF is we are looking for the specific number. And the binomial CDF, it is not continuous. It is looking for the interval between a lower bound and the upper bound. So here, we should apply the binomial PDF. And the answer is around to about 0.0899. 4 decimal places, 1, 2, 3, 4. That's it. Next, find the sample of 25 pounds. Okay, trial number still 25. The p hat is a random variable that represents a proportion of the pumps that are defective. So again, if you turn to the formula page, the first of the sample proportion, the formula is p hat equal to our x, the number of favorable out of the number of sample. Okay, so if we are looking for the probability, the sample proportion greater than 0.15, which is 15%, right? That means our x value out of 25 is over 0.15. And we can multiply and simplify both sides by 25. X would greater than what? Greater than 3.75. However, the binomial distribution is discrete. The number always be natural number or 0, but here is a natural number. So x cannot be a fraction or decimal, has to be a whole number. What is the minimum whole number greater than 3.75? That is 4. Okay, so the probability x is greater or equal to 4. Because 4 is inclusive, all right? 4 is inclusive. And then, like we discussed, just mentioned a couple seconds ago, if we are not looking for the variable equal to a specific value in the binomial distribution, we should apply binomial CDF. And as we do the binomial CDF, we need a trial number 25, success 0.08, lower bound 4, and what is the upper bound? It's finite. The upper bound among these 25 sample, maximum you can have 25 defective. So 25. And after that, press the enter, find out the answer 0.1351. That's it. And then, we have extra part. So in your exam, please read the question carefully. Check each page. Ensure that you do not miss out any question or any page. All right? Last one. For the random sample of n pams, the Pn hat is a random variable that represents the proportion of pumps that are defective. Now we need to find out the least value of n such that this p hat less than 1 over n and it's less than 0.15. Again, all right, this value n, okay, the p hat n would be the x value, all right, out of the sample number, okay, x value out of the sample number. And this value you have to less than 1 out of n. N must be a natural number because n represents a sample number. And the sample number cannot be 0, at least be 1. So you can multiply n both sides and it turns to x less than 1. Now, among these samples, all right, the defective number is less than 1. So x has to be 0, okay? Then we convert the question into find out the probability among these samples, and there are no sample that are defective, or 0 sample is defective. And then we can apply our normal binomial distribution expressions. Select select the 0 from the n objects. Then the defective would be the 0.08 to the power 0. And then the complement, the non-defective would be 0.29. And how many of them? And the answer will less than 0.15. Solve this inequality. You can find out n should greater than 22.75. Again, n is what? N is natural number. So the least natural number greater than 22.75 would be 23. And that is the least sample number we can select. Thanks a lot. And we only had about 10 days to the mathematics exam. Hopefully everyone had a fully preparation for the incoming test. Enjoy and have a good rest.